Dmitri Ivanenko, professor of Moscow State University, made a great contribution to the physical science of the 20th century, especially to nuclear physics, field theory, and gravitation theory. Scientific contributions. His outstanding achievements include the Fock-Ivanenko coefficients of parallel displacement of spinors in a curved space-time, the Ambartsumian-Ivanenko hypothesis of creation of massive particles, the proton-neutron model of atomic nuclei, the first shell model of nuclei, the first model of exchange nuclear forces, the prediction of synchrotron radiation, the theory of hypernuclei, the hypothesis of quark stars, the gauge gravitation theory. Dmitri Ivanenko published more than 300 scientific works including 6 monographs and 11 volumes edited. Scientific biography. Professor D. Ivanenko was born on July 29, 1904 in Poltava, where he finished school and began his creative path as a teacher of physics in middle school. In 1923 D. Ivanenko entered Petrograd University. In 1926, while still a student, he wrote his first scientific works, with G. A. Gamow on the Kaluza-Klein five-dimensional theory and with L. D. Landau on the problems of relativistic quantum mechanics. After graduating the university, from 1927 to 1930 D. Ivanenko was a scholarship student and then a research scientist of the Physical Mathematical Institute of Academy of Sciences of USSR. During these years he collaborated with L. Landau, Fock and V. Ambartsumian, later to become famous. This was when modern physics, the new quantum mechanics, and nuclear physics were established. In 1928, Ivanenko and Landau developed the theory of fermions as skew-symmetric tensors. This theory, known as the Ivanenko-Landau-Kala theory, is not equivalent to Dirac's one in the presence of a gravitation field, and only it describes fermions on a lattice. In 1929, Ivanenko and Fock described parallel displacement of spinors in a curved space-time. Nobel laureate Abdus Salam called it the first gauge field theory. In 1930, Ambartsumian and Ivanenko suggested the hypothesis of creation of massive particles, which is a cornerstone of contemporary quantum field theory. From 1929 to 1931 D. Ivanenko worked at the Kharkov Physical Technical Institute, being the first director of its theoretical division. Ivanenko was one of organizers of the first Soviet theoretical conference and the new journal Physikaliche Zeitschrift der Sowjetunion. After returning to Leningrad at the Physical Technical Institute, Ivanenko concentrated his interests in nuclear physics. In 1932 Ivanenko proposed the proton-neutron model of the atomic nucleus, in connection with which the name Ivanenko entered physics textbooks, including school textbooks. Later D. Ivanenko and D. Gapon proposed the idea of the shell distribution of protons and neutrons in a nucleus. In 1933 on the initiative of D. Ivanenko and I. Kurchatov the first Soviet nuclear conference was called. In 1934 D. Ivanenko and I. Tam laid the basis of the first non-phenomenological theory of paired electron-neutron nuclear forces. They made the significant assumption that interaction can be undergone by exchange of particles with a rest mass not equal to zero. Based on their model, Nobel laureate Hideki Yukawa developed his meson theory. The realization of Ivanenko's far-reaching plans and hopes was interrupted, however. In 1935 he was arrested in connection with the Kirov affair. Exile to Tomsk followed. D. Ivanenko was a professor at Tomsk University from 1936 to 1938. Until the beginning of the World War II he managed the theoretical physics personnel at Sverdlovsk University and Kiev University. In 1940 he defended his doctoral dissertation. In this period, Ivanenko's scientific interest gradually shifted from nuclear physics to cosmic ray theory. In particular, he proposed a nonlinear generalization of the Dirac equation. Based on this generalization, Heisenberg and D. Ivanenko developed the unified nonlinear field theory in the 1950s. From 1943 and until the last days of his life, Professor Ivanenko was closely associated with the physics faculty of M.V. Lomonosov Moscow State University. In 1943, Ivanenko and I. Pomeranchuk predicted the phenomenon of synchrotron radiation given off by relativistic electrons in magnetic fields. This radiation was soon discovered by American experimenters. The discovery of synchrotron radiation opened a new and important chapter in modern physics as a result of its special properties and possible applications. Classical and quantum theory of synchrotron radiation was developed in research performed by students and followers of D. Ivanenko, A. Sokolov, M. Turnovyal. For their work in this area, D. Ivanenko and A. Sokolov were awarded the Stalin Prize in 1950. Two of D. Ivanenko's and A. Sokolov's monographs, Classical Field Theory and Quantum Field Theory, were published at the beginning of the 1950s. The theme of Professor Ivanenko's post-war work was mesodynamics, theory of hypernucleus, the unified nonlinear spinel field theory, gravitation theory. In the 1960s, Ivanenko did intensive scientific, methodological, and organizational work on the development and coordination of gravitation research in the USSR. In 1961, on his initiative, the first Soviet Gravitation Conference, which initiated a series of Soviet, and later also Russian, gravitation conferences, was organized. At the beginning of the 1960s, D. Ivanenko was the organizer of the gravitation section of Ministry of Higher Institutes of Learning of the USSR, which lasted until the 1980s. He was a member of the International Gravitation Committee since its founding in 1959. Theoretical physics has been enormously influenced by the Seminar on Theoretical Physics organized by D. Ivanenko in 1944 that has continued to meet for 50 years under his guidance at the Physics Department of Moscow State University. The distinguishing characteristic of Ivanenko's seminar was the breadth of its grasp of the problems of theoretical physics and its discussion of the links between its various divisions. For example, gravitation theory and elementary particle physics. The most prominent physicists in the world participated in the seminar: N. Bohr, Dirac, Yukawa, Schwinger, Salam, Bohr, Prigogine, Wheeler et al. In the 1972 ATS, Ivanenko was concentrated on gravitation theory. His scientific team mainly developed different generalizations of Einstein's general relativity, including scalar tensor gravitation theory, the hypothesis of quark stars, gravity with torsion, gauge gravitation theory, and others. In 1985, Ivanenko and his collaborators published two monographs, Gravitation and Gauge Gravitation Theory. The scientific style of D. Ivanenko was characterized by great interest in ideas of frontiers in science, where these ideas were based on strong mathematical methods or experiment. Professor Dmitri Ivanenko died on December 30, 1994 at the age of 90.